Hi ladies and gentlemen, here's another one of my recorded little lessons to help you. We are looking at lessons that are dealing with 1.14 and 1.15, I believe, and I'm just checking that real quickly to make absolutely sure, and that is correct, 114 and 115. Okay? So this is 114 and 115. So where should you all be in the course right about now? You should be at least through the mid-unit exam, which was after unit lesson number 10. Don't forget, you can always make quiz corrections and get those into me. They need to be submitted to the corrections Dropbox. Due dates after 28 days. All the lessons that are 28 days old start closing. You don't want to wait till that point. If you're waiting to that point, you've got an issue because you won't be getting a grade for that one. So you want to make certain you're getting them in well in advance of that. Okay? So what are we talking about now? In these two lessons, you're talking about transformations. Now, a transformation is something that changes the location of an object, but not its shape. Okay? If we keep an object that is like this triangle ABC, and we simply move it around or flip it over or rotate it around, it is called an isometric transformation. Okay, that means isometric means that it stayed the same shape. Okay, shape and size. Same shape and size. That's what isometric means. So non-isometric would mean that it changes shape. Well, this one doesn't. It stays the same shape. It's a triangle here and it's a triangle over here. If you look at the distance from A to B, it'll be the same distance from A to B over here. And the same distance from B to C will be the same distance from B prime to C prime over here. So it's just a change in the object. Now, some of you might have studied transformations in the past, and you know that if I draw a line right down the middle like this, okay, the distance from point C, right here, the distance from point C to the line itself here, and the distance from the line to point C prime will be identically the same. And the distance from point A to this line will be the same as the distance as point A prime to that line. Those will be the same distances. This is called a reflection. If you go look in a mirror, you always appear the same distance from that mirror as you are from that mirror. So your image in the mirror appears the same distance as you are. And that's what we're talking about here. We've got a pre-image, that's what this ABC is, and an image, A prime, B prime, C prime. This is the mirror image of it. So this is the image, and this is the pre-image. This is the original. This one is the image, okay? That's how you can tell them apart, is with those little tick marks, those little prime marks on them, okay? So this one is a reflection, okay? Now let's look at this one. This one is a little bit different. Let's see here. It kind of goes from D, goes all the way down to here. And E goes all the way down here. It's not like it's a line that I could draw and I could see where it is. Oh, you know what this is? I'm going to tell you that this one is a rotation. If I take a point and nail a stake in the ground right here, and then tied a rope onto D, and I said, okay, let's go around. It rotated around to here. And if I tie that rope onto E, it would go same rope. It's the same distance from this point right here every time. Now, what would actually happen is I would wind up with a image that would look like this out here, like that. So it is first of all rotated around and then reflected across a line this way. So it is a combination of two different types of transformations. It's both a rotation and a reflection this way. Okay? That is not an uncommon type of isometric transformation, to see two things being done. Okay? This one is a rotation and a reflection all at the same time. Okay? What about this one? Well, this one, it just seems to move from here to here, and it goes from here to here. You know what? This one is what we call a slide or The technical term is translation. It moves from one location to another location. This is the same as your mouse on your mouse pad. If you put your hand on your mouse and you move it along, you translated it. You moved it around a little bit, okay? That's the type of transformation. It keeps the object the same shape and size. It just moves over a little bit. So it is isometric, and it's called a translation. Okay? So those are the three types of transformations that you'll be identifying in these two lessons. A rotation, a reflection, and a transformation, or a combination thereof. Okay? Those are the types of transformations that you're going to be making, and they're all isometric. They keep the same shape and size. That's what isometric means, keeping the same shape and size. Oh, wait a second, Mr. Green. Look at this one. It's smaller. The image over here, see, that's got the primes. The image, see, that's got the prime right here on the B prime. The image is much, much smaller than the original pre-image, B. Okay, this is the original image. This is the image of it, and it's much smaller. It got shrunk. It's a shrinky-dink type thing, right? Well, this is called a dilation. And I know you've heard the term before. If you've ever been to an eye doctor, the doctor puts drops in your eyes and he makes the iris in your eye get bigger so he can look inside your brain. Ooh, scary thought. Okay? But he can look inside and see what's going on. That's called a dilation. He dilates your iris so he can look inside your eye. Okay? A dilation changes the size of an object. So it is not an isometric transformation, but it does just move the object, keeps the same shape, doesn't it? So a dilation is non-isometric, but it is a different type of a transformation. Okay? So let's write these down so that we get all three of them written down in some place so that we know what we're talking about. One of the first ones you'll understand is a translation. Translation. One of the next one is a reflection, R-E-F-L-E-C-T-I-O-N, reflection. Then there's a rotation. Okay? And then the last one is a dilation. Now, these three up here are isometric. This one down here is not isometric. Okay, I'm being very specific here and making certain you understand that. When you get to the part 2 of the unit exam, you will have to identify for me a translation, a reflection, a rotation, that they are isometric transformations. And you'll have to identify that a dilation is a non-isometric transformation. You need to know those terms because you will see them again, okay? This is one of the things that we do in geometry, is we do some things like this. Now, for a transformation, one of the things that we can do is give it a rule. What am I talking about, a rule? It is an algebraic rule that allows me to take any point that might be on the object. Like, example, point B down here is at the location 2, 1. So B is at location 2, 1. That's its location. No, Mr. Green, that's not right. It's negative 2, 1. Okay. So Mr. Green made an algebraic mistake there too. So it's at negative 2, 1. And the rule for it, see how this little arrow says? That's the rule. The rule says that the new image, the new image, is going to be at x plus 3. So I'm going to take negative 2 plus 3, comma, and the y is going to be at y minus 4. I'm going to take 1 minus 4. Okay, well, negative 2 plus 3, that's going to give me a point location of 1, comma, and 1 minus 4 is a negative 3, negative 3. Guess where my new point B is going to be? It's going to be at 1, negative 3, right there. That's where my B prime is going to be. I can do that with each of the points that are on here. I can do it with A. A is at 1, 2. So if I stick a 1 in here, 1 plus 3 is at 4. So that'd be 1, 2, 3, 4. And 2 plus minus 4 is a negative 2. It'd be right there. Okay? That's where my A prime is going to be. C is sitting here at negative 3, 4, negative 3, 4. So it's going to be at x0 and y0. So it's going to be right there at that point right there. And I could connect those 3 points, and I just located and did a transformation of that using the rule. Okay? I transformed that triangle using this rule right here. It's really an easy activity to do because once I find a point, all I've got to do is add 3 onto the x or subtract 4 from the y, or whatever rule that they give me to use for that particular transformation. It's an easy rule to use and to access. This is also on the unit exam. There's a question in the true false, there is, or in the multiple choice, and there is also a couple of questions that you will have to answer on the part 2, where you're going to be asked to take a point or take an object and transform it, give it a rule, showing how you arrived at the new points, showing how the new location of the object, and showing the object itself. You have to do both of those things to get full credit for the problem. So I want you to make certain you're doing it. Don't forget, if you're trying to contact me, always include your course name and section number. I appreciate you guys that have been doing that already. It really helps me locate you quickly and answer your questions as quickly as I possibly can. Okay? So, what have we been doing? What have we been doing? We're using the teak that is in the course material. It says to use properties of transformation and their compositions to make connections between mathematics and the real world, such as tessellations. We have been using these transformations. We're trying to explain them to you. Okay? So, in Class Connect, bring the problems to me, both out of this unit, or out of this lesson, or out of the previous lessons, and we will try to work through them with you. Make certain you're understanding what you're doing. Don't attempt a quiz until you're ready to attempt it. I look forward to seeing you there. Have a good week.